Good morning, dear students. My name is Ferhan Mazher, and today is 26th of March 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a theory paper, and we have selected October-November 2013 Physics 5054 2-2 paper. This theory paper, which we call paper 2, belongs from the zone 2. And in this session, in this video, in this class today, we are going to attempt the section A of this paper. The section B of this paper we will solve in another video in another session, and I will also upload that. But right now we are going to attempt the section A of this theory paper, and this is Cambridge O levels physics. So let's start today's paper, and let's have a look at the question paper. So here we go. So the question paper is showing up on your screen. It's October-November 2013 2-2 paper. 1 hour 45 minutes are allowed. We call it theory paper. And the first question coming up on your screen. Here we go. A set of traffic lights hangs from the end of a metal cable. A horizontal chain pulls the traffic light to the right so that they are above the middle of the road. And the figure 1.1 shows the metal cable inclined to the vertical. The weight of the traffic lights is 240 Newton. Two of the forces on the traffic lights are the tension in the horizontal chain and the weight of the traffic lights. On the figure 1.1, mark an arrow that represents the tension in the horizontal chain, and the second part is an arrow that represents the weight on the traffic lights. So what we will do, I will draw a line here, and its arrow will be towards the right. That will be the tension in the horizontal chain. And I will draw an arrow vertically downward here, and that will be the weight. So let me show you how this is done. So here you can see I have drawn, this line shows the tension and this line shows the weight. It's a 2-mark question. Hopefully you understand. Okay, so let's move to the next part. He says the tension in the horizontal chain is 140 Newton. Use a scale diagram to determine the size of the resultant of the weight and the tension in the chain. State the scale used for the diagram. Okay, so we have to use a graphical method to find out the resultant of these two forces. The tension in the horizontal chain is 140 Newton and the weight is 240 Newton. So first of all, we have to select some kind of scale. For example, we select that 1 centimeter represents 40 Newton. So let me show you. So we have selected the scale that 1 centimeter will represent 40 Newton, and because 140 Newton was tension in the horizontal chain, so I will draw according to this scale 140 divided by 40, and that will be 3.5 centimeter. So it means that 140 will be represented with the horizontal line, and it will be a 3.5 centimeter long horizontal line. So you can see that I have drawn that line of 3.5 centimeter, which is perfectly horizontal. Then there are two techniques because the line 240, the line which will represent the weight, that will make 90-degree angle with this horizontal line. To make that 90-degree angle, there are two techniques. One technique is showing up on your screen. You can use a set square, and you can place the set square like this. You can see here the blue line has been aligned with this line. So when I will draw a line here, that line will be automatically 90-degree. It will make 90-degree angle with this horizontal line. This is one technique. The other technique can be, you can use your protector and you can place the crosshairs of the protector at the tail of the first vector, and the zero of the protector should be aligned on the arrow here. From here you count, and here is the 90, put a dot here, then join these two, this point and this point, and this line will make 90-degree angle with the horizontal line, because the weight makes 90-degree angle with the horizontal tension. And because the weight is 240 Newton, so I will draw a line of 6 centimeter. How do I know? We have to draw a line of 6 centimeter. 240 Newton divided by 40 Newton, you get 6 centimeter. So we will draw a vertically downward line of the 6 centimeter. So now you can see I have drawn both the forces, and their tails are joined. And when you place the two vectors to be added in such a way that their tails are joined, we use the parallelogram law to add the vectors. So if you want to find out their resultant, you will suppose that these are the adjacent sides of a parallelogram. So now I will complete the parallelogram, and I will show you what is the technique of. Okay, so I will open the compass 3.5 centimeter, because in the parallelogram the opposite sides are equal. So I will place the needle of the compass on the arrowhead of the 6 centimeter vector, and I will draw that arc. You can see I have drawn that arc. Then I will open the compass 6 centimeter. I will place the needle of the compass on the head of that 3.5 centimeter long vector, and I will draw that arc. You can see that arc where these two arcs intersect each other. I will join that point with the heads of both the vectors which I already have drawn, and you will observe that a parallelogram has been completed. This will be a perfect parallelogram. Then join where the tails of the two vectors to be added were joining each other. Join that point with the opposite corner of the parallelogram. So you can see that black line that shows the resultant. Measure it with the help of the scale. I have measured it. It is 7 centimeter. So 1 centimeter represents 40 newtons. So 7 centimeter will mean 280 newtons. So the resultant force is 280 Newton, and we are done with this question. So that was the question number 1. I hope that you have understood that how we have found the resultant. Okay, so let's go to the marking scheme. You can see the marking scheme is showing up on your screen for the question number 1. And I have already checked my answers with the marking scheme. You can pause the video and you can check the answers with the marking scheme. Okay, so let's move to the next question. The next question coming up on your screen is question number 2. He says figure 2.1 shows a boy moving a water container in a wheelbarrow. So he says so this is that wheelbarrow. Okay, the container has a volume of 0.15 meter cube and is filled with water of density 1000 kg per meter cube. Calculate the mass of water in the container when it is full. We know the density, we know the volume of the water. Very easily we can find the mass of the water. You know, density is mass divided by volume. So volume will be mass divided by density. And it's a 2 marks numerical. Let me show you how this is done. And here we go. So density is equal to mass divided by volume. So mass will be density multiply volume. Mass will be density multiply volume. In description, I think I have said something wrong. So mass is equal to density multiply volume, and mass will be density is 1000 and the volume is 0.15 meter cube. So the mass will be 150 kg. So the mass will be 150 kg. Okay. Then the next question is coming up on your screen. He says in the next question that it is harder to stop the wheelbarrow when the container is full than when it is empty. Explain this. You see, when the wheelbarrow is full with water, that barrel is full with water, the mass of that whole thing becomes larger because that has water in it. So the mass becomes larger. When the mass becomes larger, its inertia becomes larger, and you require a larger force to create the same deceleration. Or if you want to stop the wheelbarrow in a certain distance, and when it will be full, because it will have a larger inertia, so it will require a larger force which can create the deceleration to stop it. So I have written the answer. When wheelbarrow is full, it has more mass, it has larger inertia, so a larger force is required to bring it to rest. So that is my answer. So that was question number 2, and it's B part. Hopefully you understand. Let's have a look at the marking scheme. So the marking scheme is showing up. I have already checked my answers with the marking scheme. You can pause the video and take your time, read the marking scheme. It's very important. I always tell you, whenever I solve the paper, most of the times I check my answers, I compare them with the marking scheme. And same I suggest for you, that whenever you have solved the paper, any question, just go and check its answers, compare it with the marking scheme. Okay, so let's go to the next part. The next question is coming up on your screen, and that is question number 3. A farmer uses a hydraulic system to operate machinery that is pulled behind a tractor. 2 cylinders and a flexible pipe that joins them contains oil. 2 points keep the oil in the cylinders. The arrangement is shown in the figure 3.1. The cross-sectional area of the smaller cylinder is 0.048 meters square. The cross-sectional area of the larger cylinder is 0.14 meters square. The smaller piston exerts a force of 12,000 Newton on the oil. Calculate the pressure in the oil. We know the force exerted on the smaller piston by the smaller piston on the oil, and we know the area of the smaller piston. So I can calculate the pressure in the oil. The pressure is equal to force divided by area. So the force is 12,000 Newton and the area is also known. So here we go. The pressure in the oil will be the force divided by the area, and you know the pressure is force divided by area, 12,000 Newton divided by 0.048 meters square. So it will be 250,000 Pascal, which means 2.5 expo 5 Pascal. Hopefully you understand. Then he says the force exerted by the oil on the larger piston, you see, because that's the Pascal's principle. Whatever is the pressure created in the oil on one end, same pressure is transmitted to the other end. So whatever is the pressure created in the oil by the smaller piston, same pressure will be transmitted to the larger piston. So the pressure in the larger piston will be equal to 2.5 expo 5 Pascal also. That's Pascal's principle. So the force exerted by the oil on the larger piston, you know the pressure is the force divided by area. We know the pressure, we know the area of the larger piston. So we can calculate the force. The force will be pressure multiply area. So 2.5 expo 5 Pascal multiply 0.14 meter square. So when you multiply, you get 35000 Pascal, which is 3.5 expo 4 Pascal. I have written this unit and that the unit is wrong. This unit should not be Pascal. By mistake, I wrote Pascal. It should be what? It should be Newton, because that is a force. This should be Newton. Note it down. I made a mistake. So it should be a Newton. So hopefully you understand. Okay. So then their question is they say suggest why the resultant force on the larger piston is less than the value obtained in the second part. You see, that is the because we have supposed that all the pressure which was created in the smaller cylinder, the same pressure has been transmitted to the larger cylinder, and that's the Pascal's principle. But you know, maybe the oil has some bubbles in it, air bubbles in it. If the oil has some bubbles in it, then because the air bubbles, they are spongy, they are compressible, so the same pressure will not be transmitted. That can be one reason. The other reason can be that we have supposed that the piston is frictionless. It's when it moves in the cylinder, that there is no friction between the piston and the cylinder. But in reality, there is always friction between the piston and the cylinder. So maybe there is friction between the larger piston and the larger cylinder. So if there is friction between them, then some of the force will be used to overcome that friction. So the force actually exerted on the larger piston will become smaller, So I hope, and same way, if there is a friction between the smaller piston and the smaller cylinder, then the force you exerted on the smaller piston, that will be not used to create the pressure. Some of it will be used to overcome the friction between the smaller piston and the smaller cylinder. So let me show you my answer. He says, let me show you. Here we go. There is friction between the piston and cylinder. Some energy converts to heat to overcome the friction. Okay. Then the question is, the smaller piston moves the distance of 0.065 meter into the cylinder. Calculate the work done on the oil by the smaller piston. So, we know that the force which was exerted on the smaller piston, and now we know the distance traveled by the smaller piston. So very easily I can calculate the work done. Work done is the force multiplied the distance. So the 12,000 Newton force was applied, and the distance traveled is 0.065 meters. You just multiply, then you get the answer. So answer will be 780 joules. Okay. He says, suggest one advantage of using oil rather than air in the system. You see, oil is incompressible. So when the oil is incompressible, it can transmit the pressure from one end to the other end. The same pressure will be transmitted because the oil is incompressible. Whereas the air is spongy, so the air will not be able to transmit the same pressure to the other end. So oil is incompressible, whereas air is spongy. So these were the questions. Let me show you. Reduce the size a little bit. So these are the questions which were asked in the question number 3. And we are done with the question number 3. So let's have a look at the marking scheme. So the marking scheme of the question number 3, 2.5 x per 5 Pascal, 35,000 Newton and 780 joules. And so liquids incompressible. So my dear students, the marking scheme for the question number 3 is showing up on your screen. What you can do, you can pause the video and take your time for reading this marking scheme. And I have already checked my answers with the marking scheme, so I think I'm good. But even I say this, you are supposed to check my answers with the marking scheme. Compare them. That's very important habit. Okay, so here we go. A large test tube contains wax above its melting point. It is placed in a cool room. So the wax is in the liquid form, so it's hot, and you have placed it in a cool room. So now the temperature will drop. First, the temperature will drop when the temperature of the liquid wax, hot liquid wax, will become equal to the melting point of the wax. The wax will start solidifying. Once all the wax has solidified, then again the temperature will start dropping and it will come down to the room temperature. So here a cooling curve is shown to you. In the cooling curve, on the y-axis the temperature is represented, and on the x-axis the time in minutes is represented. So when we started at the 0 minute, our experiment, the temperature was 76 degrees, and in the, I think, 3 minutes, the temperature dropped to, I think, 56 degrees, and the 56 degrees is the freezing point, or you can say it's the solidifying, it's the melting point of the wax. So the wax started solidifying. So from 3 minutes up to, I think, 16, it looks like 16 minutes, yes. The temperature has not dropped. From 3 minutes to 16 minutes, the temperature has not dropped. This is the reason is it's the wax, the liquid wax is solidifying. So when the state change takes place, the temperature do not drop. So you can see from the cooling curve that thing is happening. Once the whole wax has solidified, so at 16 minutes, then the temperature starts to drop again. And after 30 minutes, the temperature is still dropping. Okay, so this is the cooling curve. I hope you understand this. And he says, determine the melting point of the wax. The melting point of the wax is this temperature, where this is a horizontal line. Here you have liquid, here you have liquid and solids, and here you will have solid. So this is the melting point, and that is 56 degrees centigrade. So the melting point of that wax is 56 degrees centigrade. He says the test tube contains 110 gram of wax that has a specific latent heat of fusion of 210 joules per gram. Calculate the thermal energy transferred from the wax between 3 and 16 minutes. In 3 and 16 minutes, you remember the state was changing, that it was converting from the liquid wax to the solid wax. So the state was changing, and when the state is changing, you can calculate the amount of heat given out or amount of heat absorbed. The formula is heat is equals to ml, where m is the mass and l is the specific latent heat. So mass is 110 gram and the specific latent heat is 210 joules per gram. So because here the unit of the mass is gram, so this should also be in the grams, and they are. So the units are consistent with each other. So multiply 110 with 210, you get 23100 joules, which means 2.31 expo 4 joules. So we are done with this numerical. That was question number 4A and B part. So let's have a look at what's the next question. So we are done with this. He says, state what happens to the wax between 3 and 16 minutes. I told you that because the temperature cooling curve has become flat from 3 to 16 minutes, it shows that the time is passing, temperature is not changing. This means that the state is changing. So the wax was converting from liquid to solid, or you can say the wax was solidifying. He says between 3 and 16 minutes, the temperature of the wax is above the room temperature and the energy is lost to the room. Explain in terms of molecules why the temperature of the wax remains constant. You see, when the state is changing takes place, and it's cooling, and the liquid is converting into solid during that 13 minutes, 3 to 16, that the heat was given out from the liquid wax, but the temperature of the liquid wax was not dropping. What is the reason? The reason is very simple. You see, its molecules were coming closer to each other. Their potential energy was decreasing. Their kinetic energy was not changing. So the liquid wax was giving out the latent heat, specific latent heat of fusion, and due to that there was no change in the kinetic energy, so there was no change in the temperature. Because that, let me show you my written answer and then we will check. Okay, so C first part, wax is solidifying, and the C second part, molecules come close to each other, lose potential energy. Kinetic energy of the molecules remain constant. Latent, specific latent heat, or you can say latent heat, is emitted to the atmosphere. So the heat is lost, but the temperature do not change because the kinetic energy of the molecules is constant, it's not changing. So we are done with the question number 4. So let's go to question number 4. Okay, so my dear students, the marking scheme for the question number 4 is showing up on your screen. And I can tell you that I have already checked my answers and I have compared them with the marking scheme, but you are not supposed to believe me. You are supposed to check my given answers with the marking scheme. It's a very, very, very important thing. So pause the video, take your time with this marking scheme, confirm, check, compare the answers which I have written and you have written with the marking scheme. It's a very, very important thing to excel and to get good grades in the Cambridge exam. So we are moving to the next question. The next question coming up on your screen is question number 5. It says, the first question, a physical textbook states that sound is a longitudinal pressure wave with a frequency within the audible range. Explain what is meant by a longitudinal wave. A longitudinal wave is a wave in which the particles of the medium vibrate parallel to the direction of the wave. The longitudinal wave consists of compressions and rarefactions. So it's a 2-mark question. Let me show you my written answer, and then we will continue. Okay, so here we go. He says the wave. Explain what is meant by a longitudinal wave. He says wave in which the particles of medium vibrate parallel to the direction of wave. It consists of compressions and rarefactions. So this is what is the answer. Okay, so that was the first part. Okay, the B part, he says state the approximate range of the audible frequency. A normal human ear, the lowest frequency he can hear is 20 hertz, and the highest frequency that a normal human ear can hear is 20,000 hertz. So lower frequency is 20 hertz and the highest frequency is 20,000 hertz. Okay, so the next part they are asking is the speed of the sound in air is 330 meters per second. Using your answer in the first part and calculate the shortest wavelength. Calculate the shortest wavelength in air of the sound in the audible range. Okay, so very simple. We know that the V is equals to F lambda. If you want to find out the shortest wavelength, the lambda will be equals to V divided by the frequency, because the velocity will be the same for the sound, and you want the shortest lambda. V equals to F. V lambda is equals to V divided by the frequency. The frequency should be largest. Let me show you. Then you will have the smallest wavelength. So let me show you. Okay, so the highest frequency is 20,000 hertz. The lowest frequency is 20 hertz. V is equals to F lambda. Lambda is equals to V by F. So F should be the largest. If you want the F to be, sorry, if you want the lambda to be the shortest, the F should be the largest. Okay, so that's why I will use 20,000 hertz. So 330 meter per second to 20,000 hertz. So when you divide 330 with 20,000, you get 0.0165 meter. So if you convert this into centimeter, it will be 1.65 centimeter. So I think it will be 1.6 centimeter. You can say write the answer in the meter. So that is question number 5, and it's B part. And we are done with the paper with this question also. Next question is question number 6. So let's go to the marking scheme and look at the marking scheme. So my dear students, the marking scheme for the question number 5. The marking scheme for the question number 5 is showing up on your screen, and you can see our answers are right. Okay. Now in the marking scheme, instead of saying 20,000 hertz, it says 25,000 hertz. And our textbook says 20,000 hertz. So to be on the safe side, we write 20,000 hertz. You can also write 25,000 hertz. You can see the marking scheme is using this number. And then they have not given the answer for the second part. They have only said that the student use 330 and either of the candidates' frequencies. So our answers are right. We have used this number as 20,000 hertz. That is what our textbook says. But the Cambridge marking scheme says 20. You can also write 25,000 hertz. Okay. So at an airport, fuel is pumped through a pipe from a tanker to an aeroplane, as shown in the figure 6.1. As it rubs against the pipe, the fuel becomes negatively charged, and this charges the aeroplane. Explain in terms of the particles involved how the fuel becomes negatively charged. You see, when the fuel will rub against with the plastic pipe, the electrons from that pipe, whatever pipe that is, plastic pipe or maybe some fabric pipe, the electrons from that pipe, they have transferred to the fuel, molecules of the fuel. So the fuel has become negatively charged. So electrons from the pipe, they have transferred to the fuel. So that's why it has become negatively charged. So here we go. So the fuel molecules rub with pipe, electrons from the pipe have transferred from the pipe to the fuel. Then he says, suggest and explain one problem that can arise when an aeroplane becomes charged. If the body of the aeroplane becomes charged and the fuel is also charged, when the fuel will come in contact with the charged fuel tank, there will be sparks. And those sparks can ignite the fuel and there can be an explosion. So charged fuel come in contact with charged fuel tank, spark might be produced which can ignite fuel and result in an explosion. Okay. The next question is, it says, to prevent an aeroplane becoming charged, a metal cable connects the aeroplane to the ground. Explain why the cable is made of metal and how the cable prevents the aeroplane becoming charged. Okay, the cable is made of metal. The reason is so that the charged particles can move through that cable from the aeroplane to the ground or from the ground to the aeroplane. That's why. But the metal is a conductor that's and the charges can flow through it. And then he says how the cable prevents the aeroplane becoming charged, because you can see if the aeroplane is charged and you have earthed it through that earth wire, the electrons from the ground can come to the aeroplane to neutralize the body of the aeroplane. Or if the aeroplane is negatively charged, the electrons from the aeroplane, they can through that earth wire, they can go to the ground and neutralize the aeroplane. So that was question number 6. Let's have a look at my answer, and then we will check it from the marking scheme. Okay, so that the charged particle electrons can move to neutralize the aeroplane, because the cable is made of the metal, because through the metal the charged particles can move. The metal is a conductor. In this answer you can also add a word that metal is a conductor and the charged particles can move through that metal wire. So how the charge prevents the aeroplane becoming charged? Charged electrons can flow along the cable to or from the ground. It means that the electrons can flow either from the ground to the aeroplane or from the aeroplane to the ground. The basic purpose was to neutralize the body of the aeroplane. Hopefully you understand and you can write a good answer. My wording in the last part might be not that good. So we are talking about the question number 6, and the question number 6 is showing up on your screen, and you can pause the video and you can read this marking scheme very carefully. I have already checked my answers with this marking scheme. Please pause the video, look at the marking scheme, check the answers which I wrote, compare them with the marking scheme. It's a very important thing. Okay, so we are going to the next question. The next question is question number 7. An electric saw is started at 1200 watt when working on a job that lasts for 4 days. A workman uses the saw on average for 75 minutes each day. The cost of 1 kilowatt hour of electric energy is 21 cents. Calculate the cost of using the saw for this job. So the power of the electric saw is given, the time in each day is given, and there are 4 days. Okay, and the price 1 kilowatt hour is also given. So I have to calculate the. Okay. So the cost will be power multiply time multiply price. The only precaution you have to take is the cost should be in the kilowatts and the time should be in the hours. So the power is 1200 watts, so divided with 1000 to convert it into kilowatts. The time is 75 minutes, so divided with the 60 to convert it into hours, and for 4 days it was used. And then you multiply with the price is 21 cents for each kilowatt hour. You just enter these values in your calculator, you will get 126 cents. So the total cost of using the saw for 75 minutes each day for 4 days will be 126 cents. So in dollars, it will be $1.26. So the final answer is $1.26. And I hope you understand. The B part of the question number 7 is showing up on your screen. He says the metal case of the electric saw is earthed. Explain how this protects the workman units. You see, the earth wire's resistance is less than the resistance of the human body. So if the casing of the electric saw becomes live, through the earth wire, the live current will go into the ground, and the man or the worker will be not, he will not experience that electric shock. Another thing which happens is when through the earth wire, the current starts going into the ground, the current which is withdrawn from the main supply, that will surge, that will increase. So when this will happen, the fuse in the live wire, that will become hot, and it will melt, and it will blow, and it will cut off the electric saw from the live current. So this is the benefit of the earth wire. Let me show you my written answer. Earth wire has, here I was supposed to write has. So earth wire has lower resistance than the human body. So if casing of the saw becomes live, earth wire direct the current through it to ground. Current from main supply increases, and it blows the fuse and isolate the saw from the live current. So that is our answer. I hope you understand. So we are done with the question number 7. So we are done with the questions number 7. Next, the question number 8 will be showing up on your screen. So let's have a look at the marking scheme. So my dear students, the marking scheme for the question number 7 is showing up. This is our answer. $1.26 is the right answer. And case becomes live, wire touches the case, fuse blows, current to earth, and no current in the workman. Okay. So our answer is right. So you can pause the video and you can check the marking scheme. Our answer is perfect. Okay. So we are moving to the next question. A smoke detector containing an alpha particle source is fixed to the ceiling in a room. The alpha particle ionizes the air between two metal plates so that a battery produces a current between the plates. If smoke enters the detector, it reduces the current between the plates and an alarm sounds. Figure 10.1 shows the arrangement. So here we have a smoke detector, and here we have a circuit. In these, the air will be ionized by the alpha particles coming from here, and a current will be produced. Whenever smoke comes here, it will stop the alpha particles, the ionization process will be disturbed, and then not that much current will be able to pass from this plate to this plate, or this plate to this plate. So due to that, what will happen? This alarm will start alarming. It's sound. Okay. So a technician removes the source from the smoke detector and measures the count rate of the source. Suggests 2 precautions that the technician should take when working with the source. Whenever you are working with the radioactive source, you should use tongues to hold the source and put it on the table in front of the detector. So use tongues to handle the radioactive source. And the second precaution, they can use the person who's performing, the technician who's performing the experiment, he should be wearing a lead lining suit. Then there can be many precautions. When I will look at the marking scheme, you will be able to note down. The technician measures the count rate in counts per seconds 5 times. On each occasion, the arrangement of the equipment is the same. The value obtained are 81, 77, 80, 83, and 79. So that's why the values are different. You see the emission of the alpha particles, or you can say the radiation, is a random process. You can say it's a random process. And then he says radioactive source that emits beta particles or gamma rays are not used in smoke detectors. State and explain two reasons for this. You see, the gamma rays and the beta particles, their penetration power is larger, is stronger than the penetration power of the beta of the alpha particles. So if you use them in the smoke detector, the beta particle and the gamma rays, they will be able to penetrate few meters in the air, and they will reach the people who are in that room, and those people will be affected by that radiation. Another reason is that the beta particle and the gamma rays, their ionizing power is less as compared to the alpha particles. So the current which will be through those two plates, because the ionization will be not that much if you use beta particles and a gamma rays. So there will be a smaller current jumping from one plate to the other plate. So the alarm will start sounding without smoke. Because the smoke, the alarm was alarming, it started sounding because when the current is less, they have put such a circuit. So let me show you my written answer. So here we go. So our suggestion is use tongues or use lead clothing, lead lining, the clothing with lead lining. And the next answer, radiation is a random process, and beta and gamma have stronger penetration. They can reach to the people in the room, and beta and gamma have lower ionizing effect, so alarm will sound all the time. So we are done with the question number 8, and by this we have reached the end. The section B will start. The section B of this paper I will do in another video. So let's have a look at the marking scheme of the question number 8. The marking scheme for the question number 8 is showing up on your screen. I have already checked my answers with the marking scheme. What you can do, you can pause the video and you can take your time, read this marking scheme very, very, very carefully. And it's very important to check the answers which I have given to you or you have written yourself. It's a very, very important habit to confirm them, to check them, to compare them with the given marking scheme of the Cambridge. So the marking scheme is showing up on your screen. You can pause the video and you can take your time. So my dear students, we are done with this section A of this paper. So today, we have done October and November 2013 Physics 505422 paper. We have done the section A of this paper in this video. The section B of this paper, I will do another video and soon I will upload that in my YouTube channel. So this paper is a theory paper. It was paper 2, and that paper also belongs from the zone 2. I hope that this video will help you. It will help you to improve your answering skills. If you find this video interesting and informative, and it's helping you, and you are able to do the past paper practice, and you are enjoying it, please subscribe my channel. Also like this video. Share the link of this video onto your Facebook and onto your Instagram and onto your Twitter accounts, because that will help me to promote my channel, and your support and your compliments, they are like fuel for me. So thank you very much. It's a great blessing that I am able to help you online. So thank you very much. Have a good day. God bless you all.